I'm going to talk to you about predicting the future with statistical and machine learning models. The title was a bit big, so I just make a little smaller. But the real title is this one down here. Let me introduce myself. My name is Rebeca. Sarai is a different name. You can call me whatever you want. I'm from Recife, Brazil, and I came all the way here just for Pygodan. I'm very excited to be here. It's my first time, and everything is amazing. And I'm on a hunt for the best burger on this city, so if you have some things to tell me, just give me a tweet. I am graduating this year in computer engineering. I like code challenges and I like motorcycles. I have one. They're amazing. I work in Vinta. We are a software studio that works with clients to evolve the products. We work since the design to the back end, and we work mainly with Django and React. So, before we start, let me just say that I will talk about a few advanced concepts, and I will not have the time to explain everything, but I will put some links there, and you can just click and see the reference. So here is the slides link and some code that I make, and you can just see anytime you want. Okay, can I jump? Nice. I'm going to talk a little bit about time series, and I'm going to show you guys a motivation. There will be the problem that we will try to solve here, and then we will solve this problem with 3 models. I'm going to show you some graphs, and I'm going to show you how to build, and we're going to see some results, and it's going to be really easy to see and reproduce. Okay. This talk begins last year. I think you all know we have a Bitcoin thing. And everybody, some people make a lot of money, and some people lost a lot of money as well. And as a dual engineer, I thought, oh, I'm good with numbers, so I must understand this and be good at this. And I ended up that I was not that good. And this talk is me just trying to understand and trying to build some models and just learning. Okay, time series. Basically, is a sequence of measurements of the same variable, so it's a sequence of variables. And we see here a lot of examples, like quarterly beer production. We see here they drink a lot in Australia. IBM stock price doesn't seem like a good year that year. Annual rainfall, it's raining. Like, yeah, okay, Brazil doesn't rain that much. And we can see that we have time series, they have a few components. We see the observer pattern, we have a trend, and we have a seasonal component, and we have a random factor that moves the series. Okay, graphs. It's gonna have a lot of memes here. I don't know if I'm saying that right, but it's gonna have a lot of these. Okay, on motivation, what will be Bitcoin's price? How can one predict the future? That's the question that we will try to solve, to answer on this talk. Wow. To predict this, we need some data. And to the data of this talk, we're gonna use a Kaggle, whatever, data of this competition, because when I initially do the things I do in the values were in real, that is the Brazilian currency. So to get you guys in dollars, I'm using this data set that is already divided in training test data set. Here's our example. We have the high price, low price, open price, close, volume, and market cap. Okay. Here is an initial plot on our data. We see that we have only the biggest values, because we don't see any drops, but a drop happened if you don't know what Bitcoin, or if you were not here on Earth last year. And we have an histogram of the value. So we see that the frequency over the value. So we see that the most of the values are concentrating on lowest values. And this situation was a quite new situation for the community at that time. Okay, let's go to our first model. We're gonna talk about ARIMA. I don't know if I'm saying that right in English, so sorry. It's a statistical model. It's widely used to time series forecasting, and it assesses the stationarity of the process. What is stationarity? You guys have some idea what is stationarity over here? Just raise your hand. Nice. Some 8 people. Great. Here, just a really, really simple notion of what is stationary, and it's basically when the property of the series do not change over time. So the mean doesn't change, the variance doesn't change, and the series has a stable behavior. It doesn't depend on many things during the time that is observed. And the ARIMA, here's a link, and you can click and you can see a more detailed explanation on that. The ARIMA assumes that your series is stationary. It assumes for it to work. If it's not, it will not work. So you have to make it stationary for that. Other thing the ARIMA stands for is autoregressive integrated moving average. Let's talk a little bit about these words. Let's start about the middle one, the integrated part. The integrated is basically a notion of the integration, is how we make the series stationary. The autoregressive model, the autoregressive part is a model that uses the dependent relationship between the observations and some lagged observations. So we'll use past informations to predict the future. And the moving average is also a model that uses dependency between the observations plus a residual error for a moving average model applied to the lagged observations. Okay? Here is the face of the ARIMA model. This is a Brazilian meme again. I'm trying to spread this to the world, but let's move on. Here are the parts of the ARIMA model. We have the autoregressive part and the moving average part. We put together these 2 models to build this one and to give better results. We see here that we have 3 variables to determine. And one is the area of the autoregressive part, the degree of difference involved, and the order of the moving average part. And to build the model, we'll have to determine these variables. Let's start determining the degree of difference. Here, we determine this variable by making the series stationary. We can make the series stationary of these 3 ways and all these 3 ways together. And here we have a more specific link with a better explanation on how to do that, because I'm not going to talk about that. Okay. Once that we determine this degree of difference, this magic number for this talk, we're going to determine the order of the ARIMA model, that is P and Q. We will use an estimator to see the quality of the model. So we will try some models, and the model who has the minimum criterion will be the best model for us to use here. I know there's a lot of coding here, but I want you to focus on this graph. You can see this here later, is on the links that I showed you before, all this code and all the explanation. What I'm basically doing here is testing the different variations and combination of models from 1 to 4, ARIMA, autoregressive 0 to 4, and moving average 0 to 4, and I'm seeing which one has the lowest value. So here we see that the black is the minor value and is represented by autoregressive 2 and moving average 3. So based on this criterion, I see that this will be the best model for us to build. Let's build a model, just 3 lines. Look what great. Here I'm using the stats model library, and I'm passing as an input a series that is already stationary. That's why I put series diff 2. So I differentiate the series twice to make this result. And I fit the model, and then I'm going to show some results to see if the model makes sense. Here is my way of seeing if everything is according to plan, if I'm on the right track. So over there, on the top left, I see that the graph is totally different from what we see before, the one when the price is going up. Here is the series stationary. So we see that we don't have any trends, we don't have any seasonal component, and the data just look random. So it seems stationary. Here I see my normal distribution, that is what is my data is and what it should be for I have a great quantity, theoretical quantity of data. So the red line is what it should be and the blue is what I have. So it looks okay too. There on top of right, I see the distribution of my data, and on blue and on green, I see the normal variation, the normal distribution. So it looks okay too. And here, the last graph, we're seeing the will have very difficulty to say this name, so it's the parallelogram, I think, if I say that right. And I'm not gonna get into details, but it sounds good too. It looks like okay. Let's make some forecasts. I made 3 lines before, and I'm just gonna make some forecasts over here. Here I'm getting my test data, and I'm getting forecasts for 100 some steps ahead, and I'm printing the observed value, the forecast, and the test data. Here we see what my model predicts. It's a lot, but on blue we have the observed value with the stationary series. On green we have the test data, and on pinkish, reddish, that color, I have the forecast. We see that the model did not behave like any closer to what test data. Was not what I was expecting here. And our confidence interval is also very, very big. You know, we have no accuracy here. So this model actually did not behave very well. So this is a shock. Why did not expect very well? The goal of this talk is not predict Bitcoin and not to make you rich. It's to show you some models and to know when to use them. So we should use ARIMA when our data has stable behaviors, when we have consistent patterns, you know, over time, when you have a minimal amount of outliers. That's why it did not go very well with a Bitcoin problem. That is a very complex problem, and I know, yeah, it will not go well. So if you want to predict, like, when a salesperson, you want to predict your sales values, I don't know if that's the right thing to say, it could be a good solution, Arima, for you. Okay, let's talk about profit a little bit. I saw that some people that sponsor the conference also use Profit, so it's a good validation for me. Profit is a tool that was developed by Facebook, and their goal was to make easy for experts and non-experts to predict, to make high-quality forecasts. It was open sourced recently, and the best thing about Profit is that it does not require the series to be stationary. So you don't need to make any kind of process to your data. You just go there and you just use it. It's awesome. Basically, what Profit is an additive regression model, and it has 4 components. The first one is a logistic growth curve trend. The second one is a yearly seasonal component model using Fourier series. I'm very happy to say that because I studied that and it was totally worth it. The third one is a weekly seasonal component using just dummy variables. And the fourth one is a list of important dates. In this case, holidays or, I don't know, Super Bowl or things that can change our prediction and the machine do not know. Okay, this is what you need to make a profit forecast. The only concern that you have to have is to just pass your data according to their parameters. Here you set an index, then on our case is the date, and you pass the values, and it's just it. You just build the profit, you fit the model, you build a future data frame, and you make a prediction. Whew. Let's see the result. If I was in 2017, looking at this, I will buy more, and it tells me that the thing's gonna grow and grow and grow and grow, and I'm gonna be rich forever, right? So, because profit use the information that we have on the present, and Bitcoin is just, there is a problem that changes all the time. And we also see that our test data grows really spikes a little before than our prediction, but our prediction is mainly right. We say that it's gonna go up, and the price did really go up, but it doesn't get the amazing fall, not amazing, but surprisingly fall that happens at the beginning of this year. So we see that it's a good model, it's really easy, but it doesn't get the, the specificity of Bitcoin. So when profit is a good choice, with not that complex problems, I would say. So when you have, I don't know, the people of, I think, Equinox, they used to predict checking of users. So when the user is going to make a checking, so it's a good choice, and they have really good results. Okay, last model that I'm going to talk about today are neural networks. We all know this is pretty on fashion right now, on fashion, on showcase. Everybody's talking about that, and everybody's is wanting to use this. And we are not different, so we're gonna use that too. And we're gonna use a pretty specific network that is LSTM. Is a recurrent neural network that is a type of network that has the ability of retain memory cells that has long-term cells. You have the ability to choose if you have long-term cells or short-term cells. And LSTM stands for long short-term memory. And the cool thing is that you can use past information to predict future information. One thing about neural networks is that you have an input, like we have on this figure, and you only use this input to predict your output. The nice thing about LSTM is that you can use other inputs, like past inputs, really long-term input, to predict your future. Great. Let's jump to build. How's my time? Is it okay? Okay. We're gonna build, first we're gonna scale this series. We need to scale this series because for the network doesn't get based. So it doesn't get high importance to higher values and low importance to lower values. So you scale the series and put all the values between 0 and 1, and you will give equal information, equal value to all the information. The next, okay, I know, again, is a lot of code here, but I'm gonna go through all of this. First, I'm using the Keras library and with the TensorFlow backend, and I'm loading our data, and I'm setting a train data set and a test data set over there. Here, I'm building a sequential network that has 3 layers, and 2 of these layers, they are long LSTM layers, and they have 128, yeah, I think that is, neurons of each neuron. And after that, I have a processing layer of 32, and then I have my prediction, my forecast. I'm not gonna get into the specifics here about the why 3 layers, why 2 layers, why I choose 2 and not 1. But just trust me on that. That was the one. Next one, I'm compiling my model. I'm using the mean square error here as a loss function, and the equivalent optimizer. And I'm feeding the model, Here I have the result I have with my trained data. I don't know if you guys are seeing everything okay, but here I have a blue line that is what actually happened, and here I have the black line that is what the model predict. And it's actually the expected behavior, because this was the information that I used to train, so it was supposed to go very well here. Let's make an auto-sample prediction here. Auto-sample, now we're gonna predict. Okay. Here, I have on red what was predicted under my test data. I'm doing here a one-step ahead prediction, so that's why the results are quite close. Let's give a zoom on that. The results are quite close because I'm doing a one-step ahead prediction. So if I predict the things, if I want to predict the value of tomorrow with the information of today, I will get actually quite close on the results. And this was very surprising because I thought that the model would not get anything right. And this is the test data that I do not train by any means. So we see here that at the beginning, on blue, I have the actual behavior, and on red, I have what the network predicted. We see here that at the beginning, the predictions are quite closer, and as long as the time passes, the predictions are getting more sparse, and they go in just to some point the model will not behave exactly as it should. But if I predict for closer values, I will actually get, I think, quite good results. And okay, 1 minute. Where LSTM shines. Basically, when you need past information to predict the future. So text generation, you need to know what you say before or what was written before for you to say what is important. Handwriting, music generation, language translation, and you have much more possibilities on that. Okay, just summing up, making a comparative of all the things that I just told you. The animal model is extremely good when you have a stable pattern over time. Just remember that requires two series to be stationary. There's also Prophet that is really easy to build and is making for you for non-experts and experts, and don't require for you to make any transformation on your data. I read someone making a prediction when will be the best price for you to get a Uber here on New York. So it's an amazing tool. And you also have the LSTM model that you can act as long-term or short-term cells, and it can be applied to a wide range of factors. And you can also have a lot of other options, like people say that you can just scratch this thing off and you can use just convolutional networks, that they are the future, and they will predict everything for you. But I wanna just end to predict things. Let's predict the future. That is. Okay. I don't know if you can make question. Okay. The first question was about one step ahead if I'm using the test data to predict the next one, right? I make the prediction. No, I use the real value because I want to make today, I want to know the tomorrow. If I use the predictive value, it quite goes crazy. And the second question was? That was the most of my focus. I studied the other ones in college, and I tested while I was studying the class. And so I just transformed the algorithm for this problem. And the LSTM for basically all my time researching, but in the time to train and optimize, it was not. Do you mean the time that is running or the time that I spend studying? Was the most part. Okay, thank you.